Good day, Great Wolf. Today we are working on our climate and weather. Okay, geography, Great Wolf, climate and weather. Okay, so we're going to first look on the important terms that you need to understand, basic terms that you need to understand. Then from there we move on to the mid-latitude cyclone. Okay, so our main topic today is mid-latitude cyclone. Okay, so let's get to see the atmospheric pressure. So this is the pressure exerted by the weight of the atmosphere on the Earth's surface. Okay, then if you are to check areas with same atmospheric pressure, they are connected by lines called isobars. As you can see, the isobars connect the lines, areas with the same air pressure. Okay, so the pressure gradient, so difference in the pressure in the in the atmospheric pressure across Earth's surface is actually give us pressure gradient. So you find that in some cases high pressure, some places we have high pressure, and some places we have low pressure. So that difference is what we call pressure gradient. So what happens now is that if there is there is huge difference between in air pressure, okay, between two places, you find that your isobars will be scattered. But if there is if the pressure difference is very slim, like from a place or consecutive places, if there's a difference maybe of 20 hectopascals, and between consecutive areas, you find that we have isobars that are close to each other, and that describes what we call high pressure. Okay, it describes strong winds. It describes strong winds, and if you have got a huge difference in the air pressure between two places, it actually gives you calm or gentle winds. Okay, then air pressure also as air moves from high pressure to low pressure, it is deflected and changes direction. Okay, this deflection is called Coriolis force and is a result of air rotation. So you find that when the air moves from higher pressure to a low pressure, it's actually deflected and change its direction. This is due to air rotation. You get to understand as we move on with with the lecture. Okay, now so air is deflected to the left in the southern hemisphere and to the right in the northern hemisphere. Okay, we're going to repeat this until you understand it. Okay, then you must know that your air pressure is measured in what called hectopascals. Okay, so let's get to see them. Low pressure. Okay, so we are going to deal with low pressure systems, and we're going to deal with high pressure systems. Okay, so low pressure is an area of atmosphere with a lower atmosphere that is lower than the surrounding area, and lows are associated with warm air and atmospheric lifting. So as a result, lows produce clouds, precipitation, and unstable conditions. Understand something here, guys. So when we're talking of low pressure, we understand in this situation, warm air is normally lifted up because there is we have cold air and warm air. And if these two air masses meet in they do cold air is heavy and warm air is light, so it's tend to be lifted up. So as air rises, it cools down, then condenses, then actually produces precipitation. Because precipitation is heavy rainfall. Okay, that's why you find that lows are actually associated with unstable conditions. So lows include mid-latitude cyclones and tropical cyclones. So those are low pressure systems. Okay. Then we move on to high pressure systems. So an area where the atmospheric pressure is higher than the surrounding area. Okay, so highs are associated with the cooler subsiding air. As a result, high normally produce clear, cloudless, dry, and stable conditions. So you find that with high pressure systems like anticyclones. So when we're talking of high pressure systems, we're talking of anticyclones. So these are associated with normally with stable weather conditions. Okay. Now, let's start with the mid-latitude cyclones, okay? So the other name for mid-latitude cyclones is temperate cyclone, extratropical cyclone, or frontal depressions, okay? So the general characteristics that you need to understand there is that mid-latitude cyclones move from west to east. They move from west to east, and they're large system ranging from 1.6 kilometers to 2.4 kilometers per hour, okay, 2,400 kilometers per hour. So they move over large distances before they disappear. So these mid-latitude cyclones, they normally cover what you call a big distance. So they occur throughout the year, okay? You find throughout the year, they do occur throughout the year. They are low pressure systems with unstable conditions. So like I said, all the cyclones are low pressure systems. So they bring cloudy, cold, and rain weather, okay? So air rotating the system in the direction what you call in the clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. So you must always know that in the southern hemisphere, the air circulation is clockwise. In the what you call in the northern hemisphere is anti-clockwise. Okay, so they occur in families. Okay. All right. The pressure in the apex is usually around 1,000 hectopascals. Okay, so this is just an indication when you are given synoptic maps. Okay. So area where mid-latitude cyclones form. So they form on what called a polar front between 40 and 90 degrees north and south. Okay. So this is where you normally see them form. So here, what we have here. We have got polar easterlies here, and we have got what called westerlies. Okay, so these are warm westerlies because they're coming from the what called the equator. There, in the equator, they are high temperatures. Remember, so they're actually coming from what called at the equator is characterized by extreme temperatures, highs temperatures and low temperatures during the night as well. Now, what we have there is this is warm air coming from coming from the equator, so the westerlies, then polar polar easterlies. Remember the polar regions. In the polar regions, you find that in the polar regions it's very cold here in the polar regions. So the air from the poles is actually cold. So here we've got cold, what called air coming from the polars. So remember, the direction of the wind is given by where it's coming from. So here we call them easterlies. So these are called what called easterlies. And here we've got warm westerlies. Okay, they are moving to coming from the west to the east. Now, so when these two meet, that's the way what you call our mid-latitude cyclones actually form. Okay, now. Conditions necessary for the formation. So we need to have two air masses. We must have two air masses, which is the cold air mass and the warm air mass. Okay. Then so this occurs at a polar front where waves are developed to different due to different in strength of the air masses. So what we have there is when these two air masses meet, they form what called a polar front. That is that is not moving, it's just stationary, a polar front, and it will only move due to to these waves. Okay, so as low pressure develops at the apex of the wave, air starts to move in the clockwise. Remember, in the clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. Okay, so along the front, warm air rises over the cold air because warm air is lighter and the cold air sinks because it's heavy. So here, understand, when you talk of mid-latitude cyclones, think of cold air and warm air. Okay, so we must have cold air and warm air. And understand something here: cold is heavy. Cold air is heavy, and warm air is light. So when these two meet, the cold air sinks and the warm air is lifted up. So as it's lifted up, what happens now is that it rises up and it cools down, condenses and forming clouds that will bring heavy rainfall. Okay, that's what happens. So the warm air that is raising up is actually it forms clouds and brings rainfall. Okay. So along the front, warm air, all right, we spoke about that. Rising warm air cools, condenses, forming clouds, like I said now. Okay, now This is what called, these are the features of what called of a mid-latitude cyclone. So whenever you see this, you know that, oh, we are talking of mid-latitude cyclone here, okay? Because what do you see about the mid-latitude cyclone? You can see that we have this what called cold front. So the cold front is leading what you call cold air. So what we have here is cold air, what called cold air, and cold air is led by the what called cold front. And what we have here is warm sector. So this is a cold sector, remember, with the cold air. This one is warm sector, okay? It's warm air ahead of the cold air. And warm sector here is led by the what called a warm front. And always remember this circular thing, these are circular for warm front, and these are like what you call triangular for what is it, for cold front. So always remember that. Now, here is what we have. These are the stages that we're going to talk about. So we have got initial stage. So initial stage, cold air from the poles and warm air from the equatorial region meet at the front, forming this what called, you can see that what we have here, polar front separating warm tropical air and what called cold polar air. Then the two air masses move in opposite what called in direction. So they are moving in opposite directions, remember. Then what we have now is that as air mass, as warm air and cold air meet at the front, a kick or a wave occurs due to friction that causes what called a low pressure to form. So as you can see here, what we have like is that on the what called, when these two meet, okay, a wave forms here, and that result in the circulation of what called circulation of the air. So what happens now is that we have the warm air here, we've got the cold air here, and the cold air is following what called, is following what called warm air, and it's lifting warm air, and remember, when it's lifting warm air, what happens to warm air? Warm air rises, condenses, forming clouds, and actually brings rainfall, okay? Now, so the circulation clockwise in the hemisphere and clockwise in the northern hemisphere. You are done. Now, let's see what happens now. Let's see what happens now. Now, the mature stage, okay? The mature stage. So now at the mature stage now, you have a clear or a distinct what you call the view there, that we have a cold front and a warm front. Okay, so now you can actually see them. You can actually see that there is cold front, there is what called warm front, and the warm sector and the cold sector. Now, a low pressure area intensifies and the cold front and warm front develops. That's where they develop on the mature stage. And apex, which is the center, okay, the center isobars take circular pattern around the what called the apex. So remember this circular, what you call this circular, these are called isobars, okay? These are called what you call isobars. So these isobars, as you can see there, they are connecting areas with the same air pressure. Now, the cold front is what's called is a cold air behind it, and warm front has what called warm air behind it. And we spoke about this, okay? And warm air rises, what called cools, condenses, forming clouds, and rain occurs. Now, occluded stage. Remember what happens there. The cold air is following what called warm air. It's lifting warm air, okay? It's lifting warm air, and now as it lifts warm air, it's get to a point that almost all the warm air is lifted up, and now we've got a mixture. And what we have there, you actually see with what called, you actually see with alternative alternative cold front, cold and warm, cold and warm front signs here. As you can see there, we have got cold front here, warm front sign here, cold front, warm. So this actually represents your occluded stage. So cold front travels faster than warm air and eventually overtakes it and lifts all the warm air from the ground. So warm sector is gradually reduced. Okay, this is represented on a synoptic, synoptic using both symbols for the cold and warm front. So once you see these two, okay, so once you see these two here, once you see these two here, once you see this, you know that, oh, that's a completely different, because you might be asked to identify the stage of the what called MID-LATITUDE cyclone. Okay, you must be able to tell because of those alternative sign that you see. Now, dissipating stage. So dissipating stage is actually dying stage, isn't it? Dying stage, because now we are saying all the warm air is lifted up. We no longer have warm air lifted up, and that means that if we no longer have warm air lifted up, it means that there are no more clouds formed and there is no more rain coming. Okay, so that's what we're saying here. Dissipating stage, this is a dying stage. Then you start to see that rain starts what's called to die away. Okay, now here so that's what we have there. So its appearance on the synoptic chart, that's what you see there. Now let's get to see that cross section of what they call for mid-latitude cyclones. So like I was saying here, when you warm air, this is a cold front, and remember it's following warm air, and warm air is being lifted up. As it's lifted up here, is actually what we call warm air rises steeply, and it forms what we call cumulonimbus clouds. So when we're talking of what is it, what you call cyclones, okay, mid-latitude cyclones, tropical cyclones, you're going to actually see that cumulonimbus clouds are associated with the heavy rainfall. Okay, so associated with the heavy rainfall, and you find the cumulonimbus in mid-latitude cyclones, you find it in front of the cold front. So this will actually give also the conditions that you find on the what you call cold front, because cumulonimbus clouds is actually resulting in heavy rainfall. Okay, so these are very tall clouds and they are very dark. As you can see, I think you have once seen them. Okay, especially we have experienced cyclones here. Okay, so you find that when you see that those dark clouds are coming, you know that, oh, those are cumulonimbus clouds. They're very tall and they're actually dark, and that's also they are bringing what called heavy rainfall. Then as you see in the warm sector here, warm sector there is kind of clear because there is nothing going up there. The warm air is still on the ground, so it doesn't bring anything much on the ground. Now, because nothing raises it. Now here also what we have here is that, remember, in front of the cold warm front, in front of it, we have cold air again. Okay, so what we have there, warm air also goes up. Okay, on top of the vertical, on the cold air, but not necessarily being lifted up. It's not lifted up, but just goes up. So in this case here, it doesn't form what we call cumulonimbus clouds. It actually forms what we call a high and thin cirrus cloud. That's what you normally see. Those are cirrus clouds. They are normally on top. You normally see them far away. Then it also forms stratus clouds. This actually brings also what nimbus stratus, which brings actually a light rainfall or steady rainfall. Okay, so remember, it's moving. Your mid-latitude cyclones moving from west to east, Okay, now so mid-latitude cyclones, you must understand that what we call is moving from west to east. Now let's see the weather patterns associated with what we call with cold and warm front. Here, the cold front, remember what I said, wind direction changes from west to south, and it's carried by strong winds. Okay, cold front, strong winds, decrease in temperature because of the cold air. Relative humidity is high during precipitation because of what we call moisture. Okay, cumulonimbus clouds form. Okay, cumulonimbus clouds form. Why? Because of the warm air that is lifted up. Then you also have rainfall. I have rainfall from where? From cumulonimbus clouds. Then what you call poor visibility. Now, if you have got heavy rainfall, you won't also see clearly. Now, pressure decreases as cold front approaches, and and then increases as the cold sector arrives. Then cold air is followed by a rapid rise in air pressure with scattered showers. So once the cold air passes, cold front passes, you no longer have warm air being lifted up. So it means that those cumulonimbus clouds, gives you what they can, the rainfall, and what's left now is just some showers. Okay, now warm front, so wind direction changes from northwest to southwest on the warm front, and the temperature increases because warm air. Relative humidity is high during precipitation from those steady rainfall. Remember from nimbus stratus clouds. Nimbus stratus clouds lead to rain because drizzle. Visibility increases, okay, and decreasing also in air pressure. Now, warm sector. At the warm sector, remember on the warm sector, there is pressure continue to decrease because cold front is approaching, okay? Then there is warm, less dense air, and nothing is lifting this warm air. So you see that you find stratocumulus and autostratus clouds that brings no rainfall because nothing lifts the warm air. The warm air is just on the ground. So, and you've got this current northwesterly wind, occluded front. On the occluded front, we've got low temperature due to cold air on the surface, okay? Because not only occluded front, remember what we said there, the cold air catches up with what called with warm air. So what we have here is that it's it's a mixture there, and it's actually the temperature also is low because of the cold air. Now the rainfall due to uplifted warm air that left that lead to warm air that is left there, that is lifted, is also brings what called rainfall on the cloud front. Then clouds would begin to disperse as there is no longer an uplifting of warm air. The cyclone then weakens and dies out. So the cyclone dies out just after the occluded front. Now, what are the effects of mid-lateitude cyclones? So you find that mid-lateitude cyclones, remember we said it's occurs throughout the year, and you normally experience rainfall in winter, okay, June, July, August. You normally experience rainfall there because of what mid-lateitude cyclone. Then there's a very disruptive also human activities because of the heavy rainfall. Heavy rainfall is actually disrupt communication or communication how now, okay, in terms of in terms of power lines, and also your boosters and everything. Then in terms of shipping as well, it also, because remember, once you have got heavy rainfall, it actually also resulting in the rising of sea level and all those waves, okay? Now, shipping, flights also being cancelled. Remember, visibility decreases or due to what called major cyclones approaching or cold front. So the visibility decreases, so you normally see that some flights actually are cancelled. Then fishing also is actually also disturbed, okay? Then this causes heavy rainfall, thunderstorms, lightning, hail, and remember, we have in 2020, was it 2017 in South Africa, we have what called some hail, in Eastern Cape, okay, that were crashing people, cars, windows, and everything, okay, destroying infrastructure, okay. Then we also have strong winds, okay. The strong winds also destroys also infrastructure. Now, so how do you read now on the in the synoptic map, on the synoptic weather maps? So you must identify, remember what we said, you must identify the signs of what called the cold front and the signs of warm front. The triangular cold front signs, the warm front, the round markings on the on the warm front line. Then the occluded front is those what called alternate cold and warm front markings on the line. Then comma-shaped curves indicate mid-lateitude cyclones, okay? So when you see that comma-shaped curve clouds, it's actually indicated with mid-lateitude cyclones, okay? Let's get to see what we're talking about here. Now, look, by just looking at this, you see that, all right, what we have here, as you can see in this case here, this is a comma-shaped curve associated with mid-lateitude cyclones, and as you can see, the way it's scaling to the right. So it's scaling to the right, so you mean that, oh, where is this? Where are these cyclones? These cyclones, at this moment here, what is shown there, it's actually on the southern hemisphere. So once you see this scaling here, scaling to this right, to this angle, scaling like this, you know that, oh, that's what you call southern hemisphere. That's how you can identify on the synoptic map. So you must be able to tell that by just looking on the synoptic map. And by just also looking on the pressure. As you can see, the pressure is just below what you call 1,000, okay? Then what also you see there is this actually represented on the northern hemisphere. So northern hemisphere is anti-clockwise. Remember, anti-clockwise, so the clouds that you can see, the wind is actually going anti-clockwise. And as you can check here on the synoptic maps here, as you can see there, you find that it's actually scaling to the left. It's scaling to the left. So it actually shows that, oh, that's the northern hemisphere, okay? So you might be asked to on which hemisphere this this omega. You must be able to tell that, okay? Now, these are what we call isobars indicating low and high pressure. So how do you tell the difference now in the synoptic map, or what difference between what we call high pressure system and low pressure system? So low pressure system, the pressure actually increase from the center, increase from the center. Okay, remember, low pressure system, the the pressure is low than the surrounding air pressure. So you find that the air pressure increases from the center. Then the high pressure system, air pressure decreases from the center. So you find that you can see there from 1022, okay, to 116 on the high pressure. So it's actually decreasing out or moving from the center. So that's what we have. So low pressure systems, we have mid-latitude cyclones and tropical cyclones, and we have covered mid-latitude cyclones. And high pressure system, we have got what's called anticyclones, which is South Atlantic, South Indian, and Kalahari high pressure. Okay, we'll deal with that later. Now, the weather station. So here is something that you need to say. You must be able to start the weather station and able to tell what are the conditions on that day. Okay, so as you can see here, how do you show the cloud cover? So the cloud cover here. So when you see that, so here what we have here is that this cloud cover shows that it's clear. Okay, and we have a dot. Once you have a dot, it's 1/8. Okay, so cloud cover, and if you move on like that, it's overcast, it's 8/8. Okay, so the precipitation here, it shows what called precipitation. This one shows rainfall, drizzle, showers, snow, hail, fog, thunderstorms. So once you see these signs, you must be able to tell, oh, what is being experienced. There are thunderstorms, there is fog, there is what called hail, storms, snow. So you can be able to tell what people should do to avoid those or to overcome those challenges. Okay, so wind speed also, the wind speed is measured in knots. So as you can see here, we have got 10 knots. So this long, the long arrow there is actually represented called the 10 knots, and the short one represent 5 knots. So you'll be represented with those. You're not going to see the 3 knots and the 2 knots. Okay, you're only going to see the 10 knot and the 5 knots. So once you see that there is a tall one, it's 10 knots, and there's a small one, you know that it's 5 knots. So you just have to tell, you just have to know through that. So here, just looking at this with the station model here, we can see that, all right, our direction of the wind here is northwest wind. Okay, it's northwest wind, and is 10 knots as well. It's 10 knots. As you can see, we only have one long one, and the temperature here is is 25 degrees, and the dew point temperature is 18. And what we have here is fog as well. Okay, fog. Sorry, not frog. Oh, I'm very sorry for that name. Fog. Now, so we have the features of our summer synoptic chart. Okay, how do you tell that this is summer synoptic chart? It's shown by the date, indicated by the date. It's actually generally high pressure over the land. We have got low pressure over the high temperatures over the land, low pressure over the land, South Indian high pressures found southeast of South Africa, and also tropical cyclone. So that's what you find in summer. Okay, then in winter, what do you see? Those are what you see: the date, low temperatures. So that will actually tell you that, oh, now we are in winter, or this is actually summer. Okay, so this is actually basically the end of our lesson. So don't forget to subscribe us on our YouTube channel, and also follow us in Facebook, Instagram, and Twitter on our so that we can keep you updated with our tutorials. Okay, so until next time, thank you so much.